Okay, so for question 5, it seems you're able to deconstruct what is the amount of the stated particles for option A and option B. For option A and option C, but for option B and D, you seem to have a bit of trouble with that. Okay, so and I have no idea what you have written over here. Is it mole per dm cube? Because what you are calculating is for the amount, which is the unit of mole. So I'm not sure what you're trying to do over here. Okay, so just take note. What you're calculating for is for the mole and not for concentration. Okay, so we just go through each option by each option, but first let's do the normal method of how we should approach a mole concept and stoichiometry question over here. So we see that okay, balance equation and limiting reagents don't seem to apply for this question because there's no reactions occurring. So what we are going to do is to apply the formula whereby we try to make sure that we are converting everything in terms of number of moles. Okay, and you can see over here that we have to find out what is the largest amount, and the largest amount will have been in terms of moles, so we want to calculate in terms of moles, and then the stated particles. Okay, so what it means is that it could be okay, it means elementary entities. So this means it could have referred to atoms, it could have referred to molecules, it could have referred to ions, or it could have referred to electrons. Okay, so you have to be very careful of what they are talking about here. So you should highlight, okay, this is talking about atoms, this is talking about molecules, this is talking about ions. Right, so option A, you are given the mass and you are also given the AR if you look at the periodic table. So you can calculate for what is the number of moles of iron over here. Okay, so mass, so 50 divided by the relative atomic mass of the relative atomic mass of iron. So let's take a look. Okay, iron is 55.8. Okay, fifty over 55.8, that will give you 0.8960. So this is for SF, and then the final answer will have been 0.896 mole. Okay, and part B, right? The molecules, okay, H2S molecules in 5 dm cube of H2S gas at STP. Okay, so you're given the volume over here. You also given the, you can find the MR, but then MR is not really very useful when you're given the volume, because MR you can only use MR and it will be only useful if you have the mass, as you can see over here in the table in this flowchart. Okay, mass and then molar mass. Okay, so if you want to, molar mass is only useful if you are given the mass. So that's why if you are thinking okay how to incorporate the molar mass, you are not able to do so because you're only given the volume. And if you're only given the volume, what you should do is to find the molar volume. Okay, the volume of 1 mole of gas, and they say it's at STP over here. So STP, it will have been 22.7 dm cube per mole. Okay, so that's the molar volume. Okay, and this is at STP. Okay, so right, number of moles of H2S molecules equals to 5.0, so the volume divided by the molar volume, which is 22.7 dm cube per mole. Okay, and that will have given you 0.2202. Okay, to 3SF will have been 220. Okay, let's go on to option C. Okay, you're given the mass, right? Given the mass 50 grams. Okay, mass is given. You can also find for the MR over here. Okay, so the fact that you're given the mass, you are able to make use of molar mass, and molar mass will have been useful over here. Okay, so 50, okay, C6H12O6, okay, 50 over 6, 12.0 plus 12, 1.0 plus 6, 16.0. Okay. See, notice how I write in terms of one decimal place for all the relative atomic masses of each element. So that is how you should present your working if this was an open-ended question. Okay. Given 0.2777, which you round it off, it will be 0.278 mole. Okay, and for the last part, for ions, you're given the volume and the concentration, and notice how the units are different. When the units are different, you need to take note 1 dm cube equals to 1000 cm cube. Okay, so this is a unit conversion, right? You can also find for the MR over here, but realize that mass is not given, so that's why we can't make use of this. Okay, be careful over here, this says ions, and 1 mole of sodium chloride can give you 1 mole of Na plus ion, as well as 1 mole of Cl minus ion. So this means you have to multiply this by 2. Okay, so over here, okay, calculate the number of moles of sodium chloride. It'll be volume times concentration. Okay, so 80 over 1000 times 5.0 mole per dm cube. Okay, because I'm converting cm cube into dm cube, you need to divide it by 1000. Okay, that will have given you 0.400 4000 mole. Okay, if you want to calculate for the ions, okay, it will have been multiplied by 2. Okay, and then when you compare these numbers, you realize that this is the biggest and the largest amount of the stated particles. Okay,